Hello, this is Unbuff76, and today I would like to look into fluid particles, mainly into recreating the scene I posted a while ago where the fluid particles were falling down, they were hitting the rotating object, and they were spread around the scene. So, right click on the default lamp and press delete to delete it. We will not need the light at this stage. Now press 1 and then 5 on the numpad to go to the front orthographic view. In case you don't have numpad, you can choose the views from the view menu, and you have all of the views including perspective and orthographic view. Right click on a cube and let's move it up for a couple of blender units. So press G, Z, 7 and then enter. So the cube is moved for 7 blender units on a Z axis. Now let's zoom in to our cube. Go to the modifiers tab, add bevel modifier, and we should apply the bevel modifier right after adding it, because we need to have a possibility to select the faces of the beveled object. In case we would not do that, then if we would go to the edit mode by pressing tab, as you can see, we are able to select only the vertices, edges or faces of the original object, and this is not what we want. So press tab to exit the edit mode. Let's apply the bevel modifier, and now let's go back to edit mode by pressing tab. So as you can see, I'm able to select the vertices because I'm in a vertex selection mode, or edges, so the second icon goes for the edge selection mode. And since we are interested in faces, so let's click on a third icon, which is face selection mode, and we are able to select faces. So right click to select the bottom face, press 1 on the numpad to go to the front view, and press E to extrude and hold your control key and move mouse to move the face down to the bottom. As you can see, when I'm moving my mouse, the face is snapped to a grid. This is because I'm holding my control key, so I can place the face more precisely. So now right click to select one of those faces and press E to extrude 4 to extrude it for 4 blender units. Enter. And let's repeat that. Right click to select E to extrude for enter, and let's do that for 2 other. Right click E for enter, and right click E for enter. Press tab to exit edit mode, and we have our object. So make sure that the 3D cursor is at its original position. In case it's not, in case it's somewhere else on the screen, you can very easily bring it back by pressing Shift C, and now press Shift A to add a plane, and let's scale the plane so press S to scale, then 70 and enter. The reason I'm scaling this plane to be quite huge is that I would like to avoid that the falling particles which will be spread around by the object would fall off the edges of our floor. So 70 should be fine. I mean, the size, making the plane bigger for 70 times should be enough. Now, when we have our plane selected, let's go to the Physics tab and let's click on the Collision button. Now we will look into the particle damping and particle friction. So damping defines how the particles will behave when they will be hitting the object. So in our case, when the particle will hit the floor, they will jump off with the energy, and the energy will be defined by the damping. So if damping will be set to 0, the particles will hit the floor and jump off with the same amount of energy they were emitted with. If the damping would be set to 1, particles would hit the floor and stay there because they would give away all the energy. Or in other words, the object would consume or absorb the entire energy of the particle. Since we are talking about fluids, so the fluids don't have to jump off from the floor, so let's go for some like a 0.9. So still the particles will hit the floor and maybe jump just a little bit as the fluid would behave. So let's add some randomness for 0.15, and that would mean that some of the particles will jump higher or lower than the other ones. And friction defines how the fluids or how the particles would behave on a surface of the object. When the friction is set to 0, the particles would be able to freely move over the surface, and if the friction would be set to 1, the particles would not be able to move on the surface of the object. I will go for point 2, so the particles will be able to move, maybe not as freely as with 0 friction, but still they would be able to move. And let's go for randomness, so set it to 0.1. In case you're wondering what those other settings are doing, so they are not relevant for fluid animation, but the kill particle setting is obvious, so whenever there will be a collision, the particle will disappear from a scene. Permeability means what is the chance that the particle will get through the object, and stickness defines how particles will stay on the surface. So more or less this looks like the same as a damping, but definitively we will not use them for the fluid animation. Now let's right click on the object and let's set collision for it. So press collision button, and then since the object will be rotating, I would like to have my particles to jump with a little bit more energy than in comparison to the floor. So let's go for less damping, and I will go for 0.7. And let's set our randomness to 0.15, and then friction the same as the floor, so 0.2 and then 0.1. Now let's start to animate the object, to rotate it, but before we will do that, let's define how long our animation will be. So by default we have 250 frames, so I will go for 400, and make sure that you're on a first frame, make sure that the object is selected, press 7 to go to the top view, and press I and then choose rotation. So the keyframe for rotation will be inserted on the first frame. And now let's go to the last frame, which is 400, and scroll up to the rotation section, and since we have 400 frames, let's go for 4000 degrees. So click on a Z and type 4000, enter, and insert keyframe. So press I and insert rotation keyframe. Now let's play the animation. So press Alt A, and as you can see, the object is rotating. At the beginning it's slower, then it's faster, then it's getting faster, and then at the end it will slow down. The reason for that is that the curve which is defining how the object is rotating, or the curve which is distributing those degrees over the time frame, is not a straight line. It's more or less like a sinusoid. In order to see this line, click on this icon and go to the graph editor. Make sure that you do that with the object selected. So as you can see, this line, the blue line, is not a straight one. So that's the reason the object is rotating slower, and then it gets in faster in the middle and then slows down at the end. So in order to make it a straight line, which would mean that the object will rotate with a constant speed through the entire animation, click on a key, go to the interpolation mode and go linear, and that will make the line, the curve, a straight line, and the object will rotate with a constant speed. So click on this icon, choose 3D view to go back to our object, and then press Alt A to play the animation. And as you can see, the object rotates with the constant speed. And now let's add the dupli objects. So those objects will be emitted instead of particles. So let's go to new layer and press Shift A to add UV sphere. Set it, make it smooth, and go to the object data and change the name of the sphere to red sphere. Renaming objects is a very good practice, because if you have multiple objects of the same type, like multiple spheres, it's always making life a little bit easier when you have the meaningful names. If we would go with the standard Blender names like Sphere 001, Sphere 002, and so on, this would be quite difficult to pick up the right sphere or right object from the drop-down menu. So on offside comment, so go to the materials, click new to add new material, and let's give it a color according to name. So let's make it red, and I will go for dark red. Feel free to go for any color you prefer, and let's add another 3 spheres. So press Shift A to add a sphere, go for UV sphere, set it smooth, press G to move it, and I'm moving it. It does they can stay here in the same spot. It's irrelevant, but I just prefer to see the objects. So with the sphere selected, go to the object data, and let's name the sphere to black sphere. And as you can guess, we will give it a color, black color. So go to the materials, click new to add new material, and like let's make it black. And now press Shift A, add another UV sphere, press G to move it, set it smooth, go to the object data, and this time let's go for yellow. So yellow sphere, go to the materials, click new to add new material, and let's make the sphere yellow. Now we'll go for dark yellow, and let's add another one. Press Shift A, you add UV sphere, set it smooth, press G to move it out of this place, and go to the object data, and let's call it blue sphere. Let's go to the materials, click new, and let's make it blue. Good. So press Ctrl S to save the file. Blender likes to crash from time to time, so it's always better to save often. Now let's go back to the first layer and press 1 to go to the front view. Make sure that the 3D cursor is at its original position. Press Shift A to add a plane, and let's move the plane up for more or less the same size as our object has. So press G, Z, and let's go for 15. And this is fine. So press 7 to go to the top view. And now I just noticed that we are on a 400 frame, so make sure that we are going back to first frame. And let's scale the plane. So press S.5. So the plane would have half of its original size. And now let's place the plane at the edge of the cube. So press G to move it, and let's place it at the edge, and press Shift D to duplicate the plane, and let's place it on another edge. Press Shift D to duplicate it again, place it here, and then press Shift D to duplicate it yet again, and place it at the edge of the cube. And since we don't really see those planes, so let's make our life a little bit easier. So press Z to go to the wire mode, and we can see that much clearly. Now let's add the particle systems, because I think we have done everything what we should do. Yeah. So having this plane selected, let's go to the particle tab and click plus sign to add new particle system. And let's change the settings. Let's change the name of the settings to red particles. And now let me look into some of the basic settings, and I will cover the basics which will be needed to recreate the scene. So first of all, the number of particles. That means that that number of particles will be emitted during the animation time frame, and the emission time frame is controlled by the start and end frame. Since we would like to see the particles through the entire animation here, so we need to make sure that the end time frame of the emission will be equal to end time of our animation. So let's change 200 to 400, and particles will be visible for a certain amount of time, which is defined by the lifetime. So here the particles will be visible only for 50 frames. So if the particle would be emitted on frame 100, then on a frame 151 the particle will disappear. This is not what we want. I would like to have the particles to be visible for the entire animation. So let's change the lifetime to 400. Random will define, or will give some randomness to the time, so some of the particles will be visible for a shorter or longer time. Let's not change it, let's stick with 0. Now, particles can be emitted from the vertices, or from the faces, or from the volume of the mesh. Since our plane has only 4 vertices, it doesn't really make sense to make particles to be emitted from those four places. So let's go for faces. And since we're having a plane, it has no volume, so the faces is the natural selection here. And those three settings control how the particles will be emitted. Jitter is is based on some kind of intervals which are defined by mm, those two settings, which means how many emissions per phase and how many jitter the object will have. But I don't really like this method. I always go for random, because random means that the particles will be emitted from the random places of the object. I don't really know what the grid is, so excuse me that I will not explain this. I never used grid before, I think. Now let's look into velocity. The velocity defines how with which speed particles will be emitted and in which direction. By default, the particles are emitted in normal direction. That means that the particles are emitted in the same direction the normals are pointing. So in order to see normals, we have to go to the edit mode. So press 1 on the numpad to go to the front view. Let's zoom into our plane and then press tab to go into the edit mode. And you can find normals at the bottom of the right panel. So you have two icons for normals for the vertices and the faces. I think in a previous versions of Blender, I'm using 2.63. In a previous versions of Blender, the normals were represented by checkboxes, but I'm not so sure that. But okay, anyway, let's switch normals, or let's switch display of the normals, and as you can see, they are pointing upwards. That means that if I would play my animation, they will first be emitted upwards and then they will fall down. Let's exit the edit mode by pressing tab, because particles cannot be emitted in the edit mode. So press Alt A, and as you can see, the particles are going upwards and then they are falling down because of gravity. There are a couple of ways we can change that. We can set the normal to -1. We can turn the object, we can rotate the object for 180 degrees, but the option I really prefer is go to the edit mode, and on the left panel you have the flip direction button, and that will make the normals to change their direction. Now when we will play the animation, as you can see, the particles are falling down. So you can also define mm, the energy in other directions, or you can find you can also define the emission energy into the other directions. So if, for example, I would say 1, positive 1, so particles will be emitted in the direction where the normals are pointing, plus they will also be emitted on the according to the x-axis. So press Alt A, and as you can see, they are not directly falling down, but they're also moving on the x-axis, or yeah, on the x-axis. Good. We don't want to have that, so let's leave this as 0. Random will define the random speed. Some of the particles will move slower than other, and I would leave this set to 0 as well. Now, since we are talking about fluids, let's change the physics of the particles from Newtonian to fluid. And before I will cover those settings, let's scroll down to the render and first of all uncheck emitter and change from halo to object. And now click on this field and you will have the drop down with the list of objects you can select. And as you can see, our life is a little bit easier because we see the name of the objects. If I would not rename our spheres, it would be quite difficult to say which one is red one. I mean, of course, we would know that red one is the first one, but uh, with the multiple objects, it would be quite challenging. So now let's select red sphere, and now let's scroll up and let's look into the settings. So first of all, size defines how big our particle will be, or how big this duplicate object will be. So if I will go increase the size, the size of the particle will increase as well. Let's go back to the initial 0.05. Random size will make some of the particles to be smaller and bigger than the other, or bigger than the other ones. So let's go for random 0.1. Mass will define what will be the matter, the fluid matter the particle will have. So you can use this to control whether the fluid will be more dense or more lighter. Of course, higher mass would mean more dense fluid, less mass would mean more lighter fluid. Let's stick with the mass equal to 1, but let's select two options. First, multiply mass with size, which means the blender will take the size, the different size of the objects or particles and their mass into consideration when doing all of the calculations of collision between particles or particles and objects. And another important setting is the size deflect. So when the size deflect is selected, the blender will recognize the shape of and the size of the duplicate object. If we would not set the size deflect, the blender would treat those spheres as points, which would give some strange results because when those particles would get into collision with themselves or with our rotating object or floor, when you would see them on the surface, they would not look like the spheres. They would look like semi-sphere because half of the object would be embedded into another one because the collision would not be properly detected. So the size deflect and multiply mass with size are very important for the fluid animations. Now let's look into other settings. So the forces. The Brownian force will add some randomness to the movement of the particles. This is fine for kind of smoke animation, but not really for fluid, so we will not use that for this for this emitter. Drag or damp of air means how the air will impact movement of the particles. When we will set those values to how, let's say when the values are zero, are set to zero, then the air is not impacting the movement of particles. When we set those values to some value higher than zero, then air will start to impact movement of particles, so the particles will move slower, or in case of the when the setting would be too high, then the particles would not be able to move in the air, so they will stick in one position. So for now we will not use this setting. We will use that for one of the other emitters. So we could have 4 different emitters for different settings, and then at the end we could compare how the different settings influence the animation. So or what is the difference between particle systems. So we could see that on the animation. Now, another two things which are important is the stiffness and viscosity. Stiffness defines how the fluid will be compressed. So when the stiffness is set to 0, then the fluid would be not compressed at all. The higher stiffness, then the more compressed fluid will be. And a compressed fluid will looks like mm, it will gather into some kind of clusters when the particles will be emitted. And viscosity defines how the fluid particles will behave on the surface. So with the zero viscosity, the particles will not gather, or they will not gather into clusters. They will behave like almost like a water. With the high viscosity, they will behave like a glue, oil, or something like that. So for this particle system, we will stick to the default values. So this no Brownian force, no drag of or damping of the air, stiffness 1, and viscosity set to 2. Now let's look into another thing, which is cache. By default, cache is set to 10, which means Blender stores the calculations into cache every 10 frame. And that's not really good for fluid animations, so we have to change the value to 1. So that means that the Blender will store the calculations every single frame. And another setting is disk cache, which means the cache will be stored on a disk drive, on a hard drive instead of the memory. So that gives us the opportunity to use more, or let's say higher amounts of the particles. And another thing is the subframes. So the subframes define how many calculations between frames Blender will do. So this is mm, of course, this will impact the performance, it will impact the PC performance. I mean, it will impact the baking time, but the results will be more accurate or better when subframes will be set to value more than 0. I already played with that before, so I have noticed that with the amount of particles I want to use, subframes set to 40 should be enough. So I'm going to 40 and press Ctrl S to save the file. And now let's set the number of particles to the desired value. So let's go for 35,000. And before we will start replicating the particle system on the other planes, let's make sure that our normals are pointing to the proper direction. So right click on a plane, press tab to go to the edit mode, turn on the normal display and flip direction. Press tab to exit the edit mode, and let's do the same for on next two planes. Right click, press tab to go to the edit mode, display normals, flip direction, tab to exit edit mode. Right click on a plane, tab to enter edit mode, turn normal display, flip direction, press tab to exit the edit mode, and we are done. Now right click on the plane and click go to the particles and click on a plus sign. And since we already created the particle system for the first plane, let's click on this icon here and choose red particles. And once the particles are added, make sure to click on this icon or this button with the 2 number. So this will split, it will make this particle system to be unique and separated from the first one. If we would not do that, then any changes we would have done to this particle system would be reflected on the previous one. So now this is separated, so let's call it black particles. Then scroll down. Anytime you make the copy of the particle system, then the cache returns to the default values. So change the cache step to 1. Select the disk cache. Scroll down to select our new dupli object, which will be the black sphere. And now let's play with the stiffness and viscosity. For our first plane we have used the default values, so now let's go for something higher, like stiffness will be set to 5, viscosity will be set to 10. And I think we are done here. So let's go to another plane. Let me just, okay. Right click on the third plane, click on the plus sign to add particle system, and now click on this icon and choose red particles as the source. Now press this button with the number 2, so we will make it a separate particle system. Now scroll down, change the cache step to 1, save the disk, or click on disk cache, scroll, let's name it first. So instead of red particles, let's go for yellow particles, and then scroll down to the bottom and replace the duplicate object from red to yellow. And now let's adjust the settings. So we have the default, we have higher values, so now let's go for something lower. I will set stiffness to 0.1 and a viscosity to 0.2. So this time we have 10 times less values. And we are done. So let's click on the right click on the last plane and click on the plus sign to add new particles system. Choose the source particle system and then click on this button to make it separate one, and let's call it blue particles. Now let's scroll down, change the cache step to 1, select the disk cache, scroll down to the duplicate object and change it to blue sphere. And now let's leave the stiffness and viscosity as they are, but now let's add some Brownian force and some drag and damp of air. So let's say the Brownian will be set to 0.2. So those particles, when they will be falling down, they will have some random movements. So they will behave in a quite strange way. And let's set the drag of air and damp of air will be set to 0.15. And that would mean that the air will impact the particles, so they will not be able to freely fall down. They will be stopped a little bit by the air, so it will looks like they are falling in water or in oil or in something like that. Just one glance, one final look, and I think we are done here. So let's review what we have done. So first, particle system has the default values, so the stiffness and viscosity is set to the default values 1 and 2. So we would expect that this particle fluids would fall down, they will gather in some kind of clusters. Mm, Another one will have more stiffness and more viscosity, so when it will be falling down, it will gather in more clusters than the first one. It will behave like more heavier, more goo-like fluid when it will be falling down, as well as when it will be in a collision with our rotating object. On a third emitter, we would expect that those particles would fall a little bit faster than the first emitter, and they would behave as a more lighter fluid because of the stiffness and viscosity set to lower values. And this one, we can expect some kind of random movements of the particles, especially when they will be falling down, mm, and when they will be moving after being hit by the object, as well as they will move much more slower than any of those any other particles we have done before. And now it's let's save the file. So press Ctrl S to save the file and click Bake All Dynamics to start baking, and I will stop here and I will get back as soon as the baking will be done. Goody, our baking is done, so now we are ready to play the animation. So let's zoom out a little bit and then press Alt A, and here we go. As you can see, each particle system is emitting particles in a little bit different way because of the settings we have used. So for example, the one I have selected or I have highlighted is the particle system with the drag and damping of the air. So that's why those particles are moving so slow in comparison to the others. They are also not being spread around so wildly as the other particles because the air impacting those particle movements. Same goes for example, second particle system, which has the high stiffness and viscosity. I think the settings I used here are not so good. That's why this is not really behaving as what I expected to have. But still, the difference between the first particle system, which is the default one, and this one is clearly visible. Same goes for the third one, where the stiffness and viscosity is set to very low values. So this fluid looks like more lights than or yeah or less dense than the first one. Goody. So now let's stop the animation at certain frame and let's go to the front view by pressing Nam on the numpad, and let's position camera at this place, at this view, so we'll see from the camera the same thing we see now. So press Control Alt and then 0 on the numpad, and I think let's move the camera back a little bit. So right click on the camera, press 7 to go to the top view, and press G and move the camera back a little bit. Press 0 to go into the camera mode, 0 on the numpad, and now let's move the camera down. So press G and move it down so we could see all particles. Good. Now let's change some couple of things. So let's go to the world setting and change the horizon color to something lighter. And let's check what's the value. So the value is 0.497, and let's add the same color to our floor. So let's go select, right click on a plane to select it, go to the materials and add new material, and let's add it the same values, so 497, 497 and 497, and right click on our object and yeah, let it be gray, more, yeah, so let it be grayish or something like that. And now let's go to the world settings again and select the environment lighting. So click on this checkbox and then make sure that we have high samples. I already had 20, as this is one of the default values I'm using, so let's go for a 20 for now, and let's try to render this and see how it looks like. So first of all, let me change the size and press render. And of course Hypercam crashed when I was saying last sentences, so I'm starting again. Anyway, Hypercam gave me a really hard time recently, and especially when I was recording this tutorial. That's why this tutorial is so fragmented, because I had to stop now and then. Otherwise my voice were becoming completely out of sync with what was happening on the screen. Good, and this is the one of the rendered frames. Of course, it requires more work on the lighting and on colors and stuff like that. But this is a good example how final render could looks like. What I will do is I will render a couple of seconds of the animation, and I will put it at the end of this video. And that would be all. I hope that you enjoyed the tutorial. Mm, I hope that I have explained how to set up particle systems, how the collision works, how the different settings mm, impacting or influencing the animation of the fluid particles, and I hope that you have learned something out of it. In case you like the tutorial, please let me know. In case you don't like, let me know as well. I would love to hear from you. So thank you very much for watching and see you next time. Bye.